Hi class, in this video I'll be introducing you to spatio-temporal analysis of moving polygons, also called STAMP. You've read about this in the Dale and Fortin text this week, and we're going to apply it here with the help of R. There are some really neat functions that the package Stamper has that I'm going to show you today, and maybe you'll apply it to your own data someday soon. Okay, so in this video, I'll walk you through how to plot polygons. Then we'll plot the area change in those polygons, followed by plotting distance movement using the stamp.distance function. And finally, we're going to briefly do some directional analysis using the stamp.multi-change function. We'll be doing all of this using Hurricane Katrina data that comes with the Stamper package. The first thing we'll do is load all of the libraries we need, including Stamper. You'll need to install these packages before we do this step, though, if you haven't already. We'll go ahead and move on to loading the Hurricane Katrina data. And now we'll convert the UTM data into lat-long format. Now we'll get the centroid points by running this line of code. After those few steps, we are now ready to map. So let's go ahead and map the polygons. And now we can also map the points, which represent the eye of the hurricane. And finally, to make sense of these shapes, we'll go ahead and plot the base map and tell R to create a PDF of the map. And once we give it some time, we can go ahead and pull up the PDF. And here is what it looks like. So each pair of polygons, there's a pair right here and another pair right there. They represent one day. So the pair in Florida here is where the hurricane was on Friday, August 26th, 2005. And this is Saturday, and this pair is Sunday. And this last pair here is where the hurricane was on Monday, August 29th, 2005. The black dots you see here represent the eye of the hurricane over those 4 days. So let's go ahead and move on to the next step, which is looking at the area change in the polygons we just mapped. Okay, so we'll start off by loading in the data again and doing some transformations with our data to prepare it for plotting. Now, this is a lot of code here. Okay, and we're also going to do some area conversions here to convert it into the metric system. Now we'll go ahead and plot the area change graph by running this chunk of code, which will also produce a PDF. Okay, here we go. And we get this output. So let's go ahead and first look at the black line here, which represents the total area of the Hurricane Katrina polygon. we see that the hurricane's area gets bigger the first 3 days, reaches its peak here at about Sunday night or Monday morning, and then it starts to die down. So to better understand what's going on with the Katrina polygon in black, we can look at these 3 other colorful lines. The most important ones here are the blue and red ones down below, which represent area disappearance and generation, respectively. Over time, we see that there are distinct periods of generation during early Saturday here and Sunday as well, which corresponds with times when the change in polygon area right here and right here are the greatest, as we see with this steep positive slope in the Katrina polygon area. We also see that disappearance is largest as Katrina dissipates late Monday, shown in blue right here, and the size of the storm begins to drop. So that's pretty cool. So now let's go ahead and move on to distance movements. So we'll start by loading the data again and running some transformations of particular columns in the data. Now we'll go ahead and run this line of code to convert the data to kilometers. And finally, we are going to run this last chunk of code here to plot the distance movement graph. Okay, and we get this output right here. So on this graph, we've got 3 lines, the black showing the centroid distance, blue based on Hausdorff distance, and red based on distance from the hurricane's eye. A little bit of background, centroid distance essentially means measuring the distance between the center of one polygon to the next. The Hausdorff method measures the maximum distance between the corresponding edges of 2 polygons. And finally, the trajectory or eye distance is simply the distance between the hurricane's eye in one polygon to the next. So applying these methods to this example, we see that in general, the Hausdorff distance is larger than the centroid distance or the eye distance. But regardless of this, there's a general trend that all 3 lines share here. We see that on approximately Monday and Tuesday, the hurricane begins to increase its distance movement. So now we're going to go ahead and go on to our final topic here, which is doing some directional analysis. Before we begin, we're going to split the dataset into 2 regions, north and south, to help ease analysis. We'll take a look at the north region first, using a rose diagram to see the dominant directions of polygon expansion and contraction events that correspond to different aspects of movement. So let's go ahead and plot them. Now this is a good chunk of code here, so it might take a second to run and produce the PDF of the rose diagrams. Alrighty. So this is for the north region. So looking at the set of plots, we see that the dominant direction of polygon change is in the west and east direction in each of these plots, which is likely an outcome of wind patterns from the hurricane. So let's go ahead and go back and try plotting the south region. There we go. R is working hard here, so always give it a minute to load. And so here are the plots for the south region. We see the similar west to east pattern dominating in contraction and expansion, but interestingly, we also see this spike here in southern expansion in period 6. So together, each of these plots that we've produced can help us get a better sense of the change in ecological or environmental phenomena that move over space and time. So with that, I hope that you'll find this video and the stamper package itself useful. If you have any questions, please post them in this week's discussion board. Thank you.